All right, this is Chapter 1, Lesson 9, Estimating Roots. So, last time we talked about roots, both square and cubed. Now this time we're going to talk about estimating. So the ones that aren't perfect cubes or perfect squares, we're going to talk about using perfect cubes and perfect squares to estimate the other ones, okay? So estimates square and cube roots. You know that the square root of 8 is not a whole number because 8 is not a perfect square. The number line below shows that the square root of 8 is between 2 and 3. Since 8 is closer to 9 than 4, the best whole number estimate for the square root of 8 is 3. Okay? So square root of 4, we know that that's a perfect square, so that's 2. Square root of 9 is 3. We know that 8 is between those two numbers, which is how we're getting our estimate. So it's going to be closer to 3. So I want to estimate the square root of 83 to the nearest integer. So the largest perfect square less than 83 is 81, and the smallest perfect square greater than 83 is 100. So the two in between are 81 and 100. So I plot each square root on a number line, then I estimate where 83 is. Well, 83 is closer to 81, so it's going to be closer to 9 on my number line. So since 81 is less than 83, which is less than 100, okay, 9 squared is less than 83, which is less than 10 squared, so the square root of 9 squared is less than the square root of 83, which is less than 10 squared. So that means square root of 83 is between 9 and 10. So I know that it's between 9 and 10, and I know it's closer to 81, so I'm going to use the estimate of 9. For number 2, I have a cube root, estimate cube root of 320 to the nearest integer. And this is when your cube root actually comes in handy, the chart that you have for that lesson, because you can actually go back and utilize that as well. All right, for number 2, when we're estimating the cube root of 320 to the nearest integer, so I pick a larger cube root, okay? So I'm going to pick the cube root of 216, which is 6, and the cube root of 343, which is 7, okay? Again, you can use that cube root page in your ISN, and you can use the square roots as well. It'll be very helpful for you in order to estimate, and so you can learn a couple of them that you'll know off the top of your head. All right, so I can go ahead and 216 is smaller than 320, which is smaller than 343. So I know that the cube root of 320 is between 6 and 7. But since 320 is closer to 343, I know that's going to be closer to 7. So that's going to be my estimate. All right, so you have a couple of try problems. I want you to go ahead, pause the video, try out the problems, and when you're done, we'll go over the answers together. All right, now that you've had a chance to try out the try problems, let's go over the answers together. So for letter A, I have the square root of 35. Now the square root of 35 is somewhere between the square root of 25 and the square root of 36. It's between here. Okay. Square root of 5 I know is 5, and the square root of 36 is 6. 35 is closer to 36, so it's going to be approximately 6. Okay. Square root of 170 for letter B. That's between the square root of 169, square root of 170, and the square root of 196. Well, this is 13, this is 14, so this one's going to be closer to 13. For letter C, square root of 44.8. So my perfect squares, I have 36, and I have the square root of 49. So here's 44.8. Okay. 36 is 6, 49 is 7, square root. Okay. 44.8 is closer here, so it's going to be approximately 7. Okay. You can use the little squiggly equal sign as approximating. That's what that means. All right, for letters D, I have cube root of 62. So the cube root I'm going to look at is the cube root of 27. And the cube root of 64. Cube root of 27 is 3. Cube root of 64 is 4. So for D, it's going to be approximately 4. Letter E, cube root of 25. So that's between the cube root of 8 and the cube root of 27. Cube root of 8 is 2, cube root of 27 is 3. 25 is closer to 27, so this one's going to be approximately 3. Letter F, there's the letter F, cube root of 129.6. So that's between the cube root of 125 and the cube root of 216. 125, cube root is 5, cube root of 216 is 6. So 129 is closer to 125, so this one's going to be approximately 5. All right, for example number 3, I have Wyatt wants to fence in a square portion of the yard to make a play area for his new puppy. The area covered is 2 square meters. How much fencing should Wyatt buy? So here is my area, my playpen for the puppy, okay? Square root of 2 and the square root of 2 are my 2 areas, which is what they told me in the problem. So Wyatt will need, because he's dealing with a fence, that's the perimeter. Perimeter is 4 times, if it's a square, it's 4 times whatever the length is, or it's 2 times the length plus 2 times the width. Okay, so Wyatt will need 4 times the square root of 2 meters of fencing. Square root of 2 is between 1 and 2, so 4 times square root of 2 is between 4 and 8. Okay? Is this the best approximation? You can truncate the decimal expansion of square root of 2 to find better approximations. So truncate means to end, to stop. Okay? I can estimate the square root of 2 by truncating or dropping the digits after the first decimal place, then after the second decimal place, and so on until an appropriate approximation is reached. So square root of 2 is approximately 1.414213562 using a calculator. I drop all of the decimals, I'm going to truncate it at 1.4. Okay, this is between 5.6 and 6. Okay, to find an even closer approximation, I can expand to a second decimal. Then I can truncate the decimal expansion after the first 2 decimal places. So this means I can add in square root of 2. 5.64 is less than 4 times square root of 2, which is less than 5.68. So again, we're getting smaller and smaller and smaller every time. So the approximations indicate that Wyatt should buy 6 meters of fencing. This way he'll have plenty of fencing to make sure that he has enough for his dog. Alright, so there are a couple of try problems out below. I want you to go ahead, pause the video, try out the try problems, and when you're done, we'll go over the answers together. Alright, now that you've had a chance to try out the try problem, let's go over the answers together. So, I have letter G. Letter G says Kelly needs to put trim around a circular tablecloth with a diameter of 36 inches. Use the equation C equals pi times D to find 3 sets of approximations for the amount of trim she will need. Truncate the values of pi to the ones, tenths, and hundredths place. Then determine how much trim she should buy. So pi, first off, is an irrational number. 3.14 3.1415, so on and so on. It keeps going. Okay? So that's the first thing I need to know. I need to know what pi is. From here, it tells me to use C equals pi times D. The diameter, which is D, is 36 inches. So the first approximation I'm going to do is that it says ones place, which is here. So I'm going to do, my first approximation is C equals 3 times 36. So C is approximately, we can use the little wavy, okay, is 108, okay, and that's inches. The second one they tell me to do is tenths place, so that's 3.1 times 36. Okay. 3.1 times 36 gives me 111.6 inches. And then my final approximation they tell me to do to the hundredths place, which is right here. So that's C equals 3.14 times 36. When I multiply that out, I get 113.04 inches. Okay. Then if I go ahead and I do C times pi times 36, I actually get 113.097, and it goes on forever, because again, pi is irrational. So this tells me that 113, I'm probably going to need a little bit more than that, so probably a good idea is 114 inches of trim. So again, the whole idea behind this is you're approximating. You're trying to get as close as possible without actually having to do large numbers like this, irrational numbers, things of that nature. Now, it's almost always better to overestimate than underestimate, especially in real-world situations when you're dealing with things like trim and fencing, okay? Because that way you've got more than you need, so that way you don't have to go back to the store and buy whatever you don't need, okay? So that is the end of Chapter 1, Lesson 9.